Welcome to Spring LIB.
Okay, so we've got 1 gram of p-aminobenzoic acid. And we've also got 10 mils of absolute ethanol. And what we're trying to generate, as well as with 1 milliliter of concentrated H2SO4, sulfuric acid, what we're trying to generate is benzocaine. That is, we're going to use Fischer esterification to convert our carboxylic acid into an ethyl ester. Okay, and so what we're asked to do is find what the balanced equation for this reaction be and what the limiting reagent is. So first, let's balance the reaction. Right, it's not too bad. In fact, we know that the concentrated H2SO4 is a catalyst that is not consumed in the reaction, right? Every mole of sulfuric acid used is regenerated in the final step of Fischer esterification, right? So we don't need to consider our sulfuric acid. We're purely looking at our aminobenzoic acid and our absolute ethanol. And luckily for us, this reaction is simply 1-to-1. That is, the balanced reaction is p-aminobenzoic acid plus ethanol goes to benzocaine, right? And the stoichiometric coefficient on everything is 1. It's 1-to-1-to-1. So the reaction is balanced. So really all we've got to determine is our p-aminobenzoic acid the limiting reagent, or is our 10 mils of absolute ethanol the limiting reagent, or do we have less moles of aminobenzoic acid or less moles of ethanol? So let's take a look at that. Okay, so 1 gram of our aminobenzoic acid, and if you weren't aware, the molecular weight of aminobenzoic acid is 137.14 grams per mole. So then the number of moles that we have is 1 divided by 137.14. 1 divided by 137.14 gives us 7.29 times 10 to the negative 3 moles. Okay, so we know how many moles we have of our p-aminobenzoic acid. How many moles of absolute ethanol are there in 10 mils? Well, we need to figure out what the density of absolute ethanol is, which we're told is 789 grams per mil. Right. The point of this is that now we know how many. That's grams per liter. It's 0.789 grams per milliliter, which will tell us how many grams then of ethanol we should expect to have in our 10 milliliter solution, right? So if we know grams and we know the molecular weight of ethanol, right, just like we did with our p-aminobenzoic acid, grams molecular weight tells us moles. Well, if we use that factor here, right, 46.068 grams per mole, 46.068 grams per mole, then we can get our final answer. Let's look at this. 10.0 times 0.789 divided by 460 or 46.068, and I get 1.71 times 10 to the minus 1 mole. So we have less p-aminobenzoic acid than we do our ethanol. Right? So great. The limiting reagent is our aminobenzoic.